Hello, good evening. It's not the evening at all. It is the afternoon though. Welcome to the Coding Train on a Friday, which is my usual day for the Coding Train, but this summer it has not been my usual day. I was just having a lot of trouble getting the start streaming button to start. I had restricted mode enabled on this laptop for a variety of reasons that I'm not entirely sure of. And interestingly enough, I cannot start streaming. I cannot actually, I have to, it's a long story, but I couldn't get that start streaming button to work while I was in restricted mode. But I fixed that. So here I am. How are you? What's going on? What's up? What's happening? It's really weird how you can't speak to me. Oh, I guess there is a chat. So you sort of you can type to me in the chat. It's night in India, writes Melvin. In Israel, it is 20 o'clock, which I think is 8 p.m. All right, so I have to admit something, although this is nothing new. I mean, I feel like normally I'm so well prepared and I spent all week making notes and scheduling things out and knowing exactly what I'm going to do. And then I've got all this energy and I turn on the streaming and I'm go, and I do a tutorial and I turn off the streaming and the day is over. Right now, I feel like it was I had to make a heroic effort just to make it here and press the start streaming button. So I have to admit that I'm a little bit out of sorts. But I have 2 hours today. Good news is I am planning for 2 live streams next week. So I am planning to live stream both Wednesday and Thursday, it looks like, next week. And I will publish times to the homepage of this YouTube channel thing soon enough. And so I'm hoping I'm going to get into what I really want to do. I really want to do some practical is the wrong word. I don't want to do anything practical whatsoever. I want to do some machine learning demonstrations in the browser with data. And data that might interest you or inspire you to use your own data and do something else with it. But I'm not there yet. Let me try to figure out where I am. I'm going to go to YouTube, the Coding Train. And I'm going to go to Neural Networks and Machine Learning. I'm going to go to session 6. Hello and welcome. I'm not going to watch that. All right, so this is what I have so far. I have to do this at the beginning of every live stream to just sort of recap and reframe and recenter myself. I'm going to put this over here so it doesn't block the view. You may or may not be aware there is something out in the world called TensorFlow.js. This is a TensorFlow, an implementation of the TensorFlow API in JavaScript that runs in the browser with no other dependencies. All of the math is done and computed using WebGL and shaders and all sorts of amazing gymnastics in ways that I might never understand, but opens the door and enables possibilities for us, the people who program like this. That's how I program, to try it and experiment and learn a bit about machine learning. And get our hands in there and ask the right questions and be critical about the role of AI and machine learning in our world today. So that's this. I have started doing a series of tutorials. These are not super beginner friendly. There's some advanced JavaScript, advanced aspects of the JavaScript language that I'm using that are confusing, like promises and await and async. You have to do lower level memory management yourself. When you make these arrays of data, you have to allocate the memory and deallocate the memory. And then there's all these scary weird terms like stochastic gradient descent, and well, that's one of them. Optimizer, root mean squared. So, but I'm doing this series for an audience who perhaps has already learned a bit about JavaScript programming, maybe watched some of my other basic intro to neural network videos, and just kind of follow along and see how a larger machine learning library works in the browser and can be used. So the tutorials that I have so far are sort of an introduction to what TensorFlow.js is, talking about what it is to be a tensor. What is it to be a tensor? I'm a tensor. I'm very tense all the time. I want to be more relaxed. I want to be a variable instead of a tensor. Although tensor, variable, whatever. Okay. Then variables and operations, talking about memory management. I implemented a version of linear regression, which is a kind of like a classic machine learning algorithm where you try to fit a line to a bunch of data points. Kind of serves as the foundation for a lot of machine learning research. I also looked at polynomial regression, where instead of a line, we could fit a polynomial function which curves around. And then I finally started looking at the Layers API. And the Layers API is a higher level API inside of TensorFlow.js, which allows you to create machine learning models as sequences of layers. And that has, how that works has to do with how neural networks are architected with inputs and outputs and layers that are in between. And there's different kinds of layers and different kinds of math functions that happen with those layers, all that sort of stuff. So this is where I am at the moment. This is where I am. Where am I going to? Where am I going to? Don't ask anymore. I forgot my ukulele. I learned to play the ukulele a couple weeks ago. I'm thinking of ruining this YouTube channel with me playing the ukulele. Where am I going to? Don't ask anymore. Okay. So what's next? Let me make a list. Really for me, but you're watching, so you can watch. XOR with TF layers. I want to do a classification example. I'm thinking of what I'm thinking of right now. So I'm going to go through these one at a time. Classification, and I'll come back to the details on these. I want to do image. Then I want to do image classification. Then I want to do image classification again with convolutional layer. So then I want to talk about what that is. Do I want to do some type of regression example? Maybe. Maybe. So classification, and then maybe sort of like as an aside, a B of like a basic like regression. So this is kind of what I want to do in terms of the basic building blocks of machine learning with neural networks. And I want to build all of these with the TensorFlow.js library. So just to lower your expectations for a minute. If I were able to get even just this done today, I will be very happy about that, okay? So this is kind of my goal. That's my goal for today. Now, I am doing things backwards. In one sense, I'm doing something bad. These are not super beginner friendly. I mean, they're as beginner friendly as I can make them. I want them to be friendly. But if this was my first day watching a coding video, I might not want to jump into the image classification with the TensorFlow Layers API video, which doesn't exist yet. But once I get through this, or actually once June 15th hits, or maybe even a little bit before June 15th, that's next week. I'm going to start doing some beginner-friendly, and I'm hopefully going to have guests come and do these with me. Maybe somebody who's watching this right now who's worked on this ML5 project would like to come. Beginner-friendly ML with some hearts and some stars, and like a little like rainbow, and then like there's a train going by. Oh, I can't draw a train. Oh, yeah, okay. And with a library called ML5.js. So I'm going to come back to this in a second. So just briefly, let me just show you. uke.js. It's a great idea for a... so if you go right now on the internet to a URL, ml5js.org, you will find this website. This is going to be fun. Let's do something fun here. We'll see here, right here on the home page, is this interactive demonstration. This is a picture of a robin, which the MobileNet model labeled this as a robin, American robin, Turdus migratorius, with a confidence of 98.77%. Oh, so now I'm going to upload an image. Do I have any images here? This is good. Hold on. Let's go get a rainbow. Images. This looks good. Download. Oh, we should have done a train. Let's try rainbow. .jpeg. Where am I going? Desktop. That looks good. Let's go for a train. This one looks good. Oh, save image as train. Let's go back to the ML5 web page, and what I'm going to do, I could drag and drop it, but I'm just going to do this. Let's try, whoops. Let's try the train. Trailer truck, tractor trailer, trucking rig, articulated lorry, semi with a confidence of 42.94%. Let's try doing the dragging and dropping thing with the rainbow. Bring it over here. And now we have a parachute chute with a confidence of 49.29%. So how does this work? Well, I will show you. If you scroll down here, you will see here is the code for such a thing. And so the ML5 library is a machine learning library built on top of TensorFlow.js. This library would not at all be possible without TensorFlow.js running behind the scenes to try to create some simple code examples to work with, at the moment, mostly pre-trained models in the browser. And there's lots more coming here, and I'm going to do a bunch of tutorials with this. But this project is, I'm mentioning it now because Hannah Davis at the I/O Festival, totally not in the Slack channel here, at the I/O Festival, talked about ML5 in her presentation. Hopefully the I/O Festival, which is just finished up in Minneapolis. The videos, all the talks there are amazing. Go find their Vimeo channel, and all the ones from last year you can watch, and then the ones from this year will be out soon. And we're looking at trying to launch this more officially on June 15th. And I will mention that if you're interested in kind of poking around, if you go to all of our GitHub repos, first let me just go over here. We can see here's all sorts of wonderful people who have been working on this project, more than just these 10 people, but here are 10 people. What I want to show you here is under projects. This is my first foray into using the project management tool that's part of GitHub. Did you know that Microsoft bought GitHub? Some people think that's a problem. Some people think it's great. I don't know. I'm going to just keep using it for a while longer until somebody tells me not to. Okay, so, but this project management tool is the first time I've used it. If anyone wants to jump on in and get involved and we're kind of have a little sprint here from now until June 15th. There's a lot, if you look at that website, there's a lot of stuff that's missing. There's a lot of stuff that's broken. And so, reach out to me on Twitter at Schiffman. Type in a comment somewhere on GitHub if you want to get involved and help us kind of push forward some of this code stuff for the release. And okay, so that's what I wanted to mention there. Looking in the chat, looking in the chat, looking in the chat. Okay, so now, coming back over here. So this is what's coming. This is what I hope to eventually have on this YouTube channel is a playlist which is machine learning for beginners in the browser. I don't know what to call it exactly, and I'm going to be using ML5 and P5.js for that together. By the way, the 5 in ML5 is an homage to P5 and processing because the ML5 library aspires to be kind of friendly and accessible in the same ways that processing and P5 have been over the years. And there we go. My camera's still shut off. Now, back to today. It's 1 o'clock already. So now, I have a pretty clear picture what I want to do with my image classification examples that I'm going to build. I want to use the quick draw data set. So one of my goals with making my machine learning tutorials is to use non-traditional data sets. And maybe non-traditional is the wrong word, but data sets that are outside of what you would typically find in machine learning and data science curriculum. I want to use different ones that are kind of in the creative space to get people thinking more creatively about what kinds of data they encounter in their life that they could maybe use. I want to use data sets that are really simple and kind of like easy to understand and look at. And I also want to use data sets that are representative of the world that we live in and all of the cultures and people that we share this great earth with. So things like, I'm trying to avoid things like MNIST, which is the sort of classic handwritten digits data set, things like the iris data set, which is wonderful, and I love flowers. Nothing could possibly be wrong with a flowers data set, but things that you wouldn't, that kind of maybe feel a bit more approachable. So I asked this question a bunch of places a bunch of times. I don't get any responses because maybe it's hard to find these kind of data sets. I feel like the Google Quick Draw data set is a great one for learning about image classification. And then what I'm thinking of doing, and XOR is like, it's not really a data set, it's just made up. Oh, there's something else I want to add in here. Okay, hold on. And then classification, right now the only thing, so TensorFlow.js, there's a Node version of TensorFlow.js that used this MLB, Major League Baseball data set to classify pitches. And I love that. First of all, I'm kind of a little bit of a baseball nerd. Any word, so that's kind of interests me, but I don't know that baseball is perfect for what I want to do that's going to be, a lot of people don't know about baseball and are interested in baseball. It's maybe not reaching the more general audience that I'm imagining for this channel. So, but something like that, that's really simple. So all I can think of right now, because from Jabril, go check out SEFD Science, Science, I can never say his channel name. It's probably there's a really easy way to say that channel name, and I just can't do it. I don't know why, and I'm almost falling over for no reason. I was talking about something. Data sets. Jabril's had this demonstration of a color predictor. And one of my students actually this semester created a variation on that, which was kind of predicting more about a color than just A or B. And so I was thinking of kind of using that as an inspiration. And so what if I made a color classifier that classified colors into like bluish, grayish, or aqua, like the sea, I don't know, some kind of set of arbitrary labels, like 5 to 10 labels that, but I need to, so maybe I would crowdsource that data set, I'm not sure yet. So that's what I'm thinking about for classification. I kind of had hoped to do that today, but I talk too much and there's limited time. But that's coming next week. Another thing I forgot in here. I wanted to make your own TF playground. So just briefly, one last thing that I'll mention here on this to-do list. If you go to, I believe it's playground.tensorflow.js, is that? Well, hold on. Whatever. TensorFlow Playground. This is a project from the Big Picture group, the research group from Google that created that, where TensorFlow.js itself came out of. And you can kind of create this little playground in the browser where you can configure a neural network. You can have this kind of 2D data set. You can actually, there's like a play button so you can run it and you can watch it try to either classify, and there you go, sort of classify, or I don't know if it's doing classification or regression. It looks like classification to me. They're sort of blue and orange. So I have no interest in building out something that has this level of sophistication and design, visual design, but I would like to show you, well, could you, similarly to how I made the linear regression, the polynomial regression examples, maybe I'll just do like a basic 2D classification problem with drawing stuff. Okay, so that's my introductory talk. I love this. Go, you little neurons, send that data. Whoosh. All right. I can break it. I'm very good at breaking things. All right, so that's where I am. So I think when all is said and done, I think right now I'm just going to tackle today, from now until about 2:30, which is an hour and a half, XOR. And I really am torn. Like, I don't want to do it because it's sort of, but it's good for me, so I'm going to do it. All right. But before I do that, let me see if I can get some questions and get myself organized. Anybody have any questions about ML5, TensorFlow.js, life, the universe, how to play the ukulele? All right, so what do I need to do here? There's a couple things that I need. Number one is where is website? Just looking at the, if anyone who is a sponsor, a patron, there's an interesting question in the YouTube chat that's that I might like to answer, you can paste it into the Slack channel. No, this is not right. Where am I? No. Past. Oh. Poodly, poppidly, dooby dooby wah. There we go. All right, there's two bits of code that I need to get started with this. One is the actual previous XOR. Oh, you gotta be kidding me. No, here. Here we go, coding challenge 92. And then I also want to get under, maybe it's under courses, intelligence and learning, session. Wait. No, how come it's not there? Is this a different, oh, past, in a different place. I have this in too many places. Courses, intelligence and learning, session 6, the layers API, I need that. And then P5 TensorFlow. Let's put these in there. And I don't need these anymore. And let's go over here. I don't know which would be better to start from. Let's start from this. This will be coding challenge what? What coding challenge number? Isn't this the third time we do XOR? Is it really? Oh, you're really torturing me because I really feel like I have a thing. I have a little bit of a thing, like it's kind of a little, like, you know, like I can't, if I'm listening to podcasts, like I have to listen to all of it, every minute. I can't like not listen to one episode, and I have to like, so somehow in myself, like I just have to do the XOR now with TensorFlow.js because I have to, but maybe I should skip it. What coding challenge number am I on? Did somebody tell me? No, but I can find that out. By going here, and oops. 105 was polynomial regression. So this would be 106. Okay, I totally didn't do this right. Hey, how come, there we go. Now, do I have the Atom editor open? See, here's the thing. What's interesting about doing this YouTube channel is if I were teaching a course, like I do, supposedly, at NYU, I would just skip a lot of stuff because there's like limited amounts of time. And I do, to some extent, do that here, but I have this like false, it's like this false sense of infinite time and I must do every single step, which I need to move away from. K. Weekman writes, it's a good example, comma, but, ... and I get it, but I'm waiting for what's coming next. I think I could fill it in, but I think it's, that's what I'm doing today. Unless, I mean, I'm going to do that, no, okay, that's what I'm doing. All right. So let's see. Here we are. This is my list. Thank you. XOR Schiffman. See, I think I only actually made one, even though it's like probably the third or fourth time I'm doing it on this channel. I do only have one video, it appears. Yeah. Look, here's Simon talking about XOR. Some other videos. Okay. All right. And now, did I run a server? Yes. Let me open up the browser. I would love to do like some kind of little just fun algorithmic thing, the equivalent of like phyllotaxis today before I go if there's time, but I doubt there is. Okay. All right. Yeah, see, Guy writes, I missed the non-machine learning coding challenges. Totally agree. Yeah, I don't know. Burger Bob asks, could you please read the chat more often? I totally get the sentiment. I appreciate the question. I can certainly try. It is very hard to follow the chat and do the live stream at the same time. And maybe someday I will have a better system for doing that. I have some ideas for how to do that, but I need time to get some more screens and maybe have some help with that and that sort of thing. All right. Ada, she writes, did he say filing taxes? Yes. And now, coding challenge number 327. Filing your taxes. Let's go see. IRS tax filing API. Ooh. IRS Gov e-file provider software developer. Ooh. Okay, I guess XOR isn't so bad. Phyllotaxis, the beautiful Fibonacci spiral pattern of a sunflower. That's what I was saying. All right, see what happens. Burger Bob, that's exactly, Burger Bob, what about a giant screen which shows the chat behind the camera? That is exactly what I would like. And I will snap my fingers, and giant screen will be mounted there behind the camera. Somehow that didn't happen. I'm not sure why. So I do like that suggestion. Oops. Yes, Chris writes, might be worth having a mod pull interesting questions out of both chats and give them to Dan at Q&A breaks. I'm absolutely game for trying that and wants to sort of volunteer. At this point, I think I would need a volunteer to help facilitate that. That would be great. All right, let's. Let me get over all of my anxiety and hang-ups about you doing XOR again and talk about them when I start. And then And then I will begin. I see all these people typing, and Ada, and Kay Weekman, and Eric, but I got to move on. I think I got to start, because time is a wasting. Yes, thank you. Okay, Eric in the chat writes, sometimes it's important when learning something new to base your exploration around an example which is fairly trivial and you understand intimately well. Truer or better, I could not have put it better myself. Thank you. I'm going to read that sentence at the beginning of this coding challenge, if you don't mind. Hello, welcome to a coding challenge. Now, I know what you're thinking. I mean, I don't know what you're thinking, but I know what I'm thinking. That looks like coding challenge number 92. XOR, which is probably one of the less interesting, creative, like sort of just technical coding challenge demonstrations that you've done. Why are you doing it again? Well, Eric from the Coding Train community writes a nice explanation, because I was, just before I started this, having a real hang-up about this. Sometimes it's important when learning something new to base your exploration around an example which is fairly trivial and you understand intimately well. So here's the thing. I am learning something new. Well, come back here. And the thing that I am learning something new is this TensorFlow.js thing. And wouldn't it be fun to make, like, play Pac-Man with it, or the emoji scavenger hunt project, or Teachable Machine, or play a piano with it, all these things. Ooh, PoseNet, oh my God, we got it, I want to get to this. And I could just sort of go there right now. I will get there eventually. But I'm trying to learn the basics of how the library works, and I'm trying to step through this slowly. So I will say that if you're watching this video right now, where you are is not necessarily in the most beginner-friendly place, because I'm working with TensorFlow.js natively to implement basically like a weird math problem. It's not that weird of a problem, actually, but a very basic, trivial math problem, just to see how TensorFlow.js works. That's what I'm trying to do in this coding challenge. And in about 20 or 30 minutes, I'll be coding. This coding challenge is, just look, it's probably like 4 hours and 72 minutes long, which is why would I say 72 minutes, because that's 5 hours and 12 minutes, but I don't know what's going on. But the trajectory that I'm on is I'm going to start doing some stuff, inching my way towards, oh, let's actually use some data. Let's use some more data and maybe some images. And so I've got a bunch of things that I'm stepping through, and I'm trying to get to the point where I'm going to use this other machine learning library called ML5, which at the time of this recording hasn't really officially been released yet, but builds on top of TensorFlow.js. Thank you, everyone who made TensorFlow.js, wherever you are, to try to create some more accessible interfaces to some of the algorithms and models things that you can do with TensorFlow.js without having to do the lower level memory management and math operations stuff. So all of that is coming, and I just took a lot of time in this coding challenge to say that to you. So, but as much as I kind of I'm not so sure, but what I'm going to do, so why is XOR? So here's the thing, this is why. I need an example. This is the first time I'm going to ever, in any of my videos, except for the other one that I made, but this is the first time that I'm actually going to use the TF layers API to train a model with a data set to produce a certain output, okay? I did 2 tutorials about what the TF layers API is. You could pause now and go and watch those and then come back here. But in those videos, I didn't actually do anything with TF layers, I just sort of talked through and typed out some code. So the problem that I want to solve, and apologies for explaining this probably for like the 15th time on this YouTube channel, is very well known from machine learning, XOR, because when the original perceptron was invented, the single perceptron, the model of an individual neuron that could receive inputs and generate an output, it could not solve XOR. It just couldn't. It's not a linearly separable problem, and I've talked about that in other videos about why we need multi-layer perceptrons. So the nice thing about XOR is I can diagram for you. Hold on a sec. I'm back. I can diagram for you the architecture of the model that we need to create. There are 2 inputs. There is 1 output. So the inputs to the XOR problem are true and false values. So if I made a little truth table, and, or, XOR, right? I can have true and true, true, false, false, true, false, false. An AND operation would only ever give me true when both are true. False, false, false. An OR operation would only ever give me, would give me true if just one of them is true. True, 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 false. Can you even see that? I can't see on my monitor, but hopefully you can. Now, XOR, the X for exclusive, gives me true only if one is true. They can't both be true, only one. So in that case, I get false, true, true, false. And the idea of linearly separable comes up here because I can draw a line here to separate true from false. I can draw a line here to separate true from false. But here, I can't draw a line. I could do this. But I can't draw a single line to separate true from false. We need a more sophisticated model with a hidden layer. So the inputs are things like a 1 and a 0. Feed forward into the hidden layer, activate, feed to the output, and the output should be a 0 or a 1. It's really, in some ways, a classification problem, but I'm going to do this as a regression, essentially, where I'm just going to get some number between 0 and 1. If you watch the previous coding challenge, the reason why that is because... And thank you very much. Good night. This video is now over. I hit my sound effect by accident because what I'm trying to do is visualize the true-false space. All right. Pause for a second. I'm just taking a pause for a second. How long was that? Like 10 minutes at least, right? But it's important. It's important for me to talk about what I'm doing. All right. So I'm just thinking here, where am I going next? Looking at the chat, no one's complaining too terribly, and I think I'm going to move on. I guess I could transition back over here in case, Mathieu, you want to edit out the weird sound effect thing. Oh, they're good sounding. Okay, that's good. Hugo asks, will you ever do non-JavaScript videos? Well, I do some processing in Java videos. Those aren't JavaScript. But at this point, I'm kind of doing the JavaScript thing. Okay, let me transition back, Mathieu. I mean, maybe the sound effect little thing was like a funny little bit, but I think I'm going to just transition back. Because ultimately what I'm going to do is visualize the output of the model, and I'm going to send in numbers all the way between 0 and 1. I don't even know what I'm saying. No, it's fine. Because ultimately I'm going to visualize the output as grayscale values, and I want to see grayscale values all the way between 0 and 1. It's the same thing I did in the previous coding challenge, if you happen to have watched that one. All right, so now I'm going to also do something where I start from the code from the previous coding challenge. And so we can see there's this idea of training data, The inputs to the XOR problem are 0, 0 gives me a 0, 0, 1 gives me a 1, 1, 0 gives me a 1, and 1, 1 gives me a 0. This is the training data. And in my previous version of this, I used my own neural network library. So in theory, I'm going to get rid of the idea of a learning rate slider, we can add that back in later. But let me get rid of the learning rate slider. Basically, I want to do exactly the same thing. The difference is I'm going to say neural network equals TF layers sequential. And maybe I'll call this the model instead of neural network. So the idea, this is neural network here. So the idea here is that I want to replace my neural network library with TensorFlow.js. And so this, for me, what the usefulness of this video is of me learning. I spent all this time trying to build my own rather sort of terrible neural network JavaScript library. And going through that was sort of helpful in thinking about how the stuff works. Now if I can translate that into TensorFlow.js, things are going to hopefully start to settle and make more sense into my brain. Bruno is asking something in the chat about the true-false table. Yeah, usually you draw it as I might come back to this later. Usually you draw it as a matrix, and I sort of did something weird there, but I think it's fine. Sorry, I'm looking at, see, this is what happens when I look at the chat too much. All right. Okay. All right. Okay, so now we need to, this constructor here said, and let's just put this back to this. This constructor here said, make a neural network with 2 inputs, 2 hidden nodes, and 1 output. So I need to duplicate that idea here with TF layers. So let's go to the TensorFlow.js API reference, and we're going to scroll down to TF layers. And what I want to make is a dense layer. TF layers.dense. A dense layer is a fully connected layer. So what I'm going to do is I am going to say let hidden equal TF layers.dense. And then I can put inside there an object that has the parameters of how I want to configure that layer. And so how do I want to configure it? The 2 things that I really need to do is, this is the hidden layer, right? I need to give it an input shape, right? I need to say what's coming in. What's coming in, that's what this is here. I need to say how many nodes it has. That's the number of units. And then it probably has a default one, but I can specify an activation function. And again, I'm just going to use sigmoid as this historical activation function that I've been using in all my videos to date. I'm going to soon talk about softmax, what that is, as well as some other activation functions like relu, which is maybe more commonly used. Okay. By the way, nobody pronounces it that way but me, so don't get confused. All right, so I want to say input shape, I believe, is there's just 2 inputs. I also want to have 2 units, 2 nodes, and activation is going to be sigmoid. So now I have created the hidden layer. Yay! The other layer that I need to create is the output layer. And so what am I going to do with the output layer? I don't need to provide an input shape because the input shape can be inferred if I add them sequentially. The inputs are not a layer, so for this first layer, the hidden layer, I've got to say how many there are. But now once I'm creating this next layer, the input shape is going to be defined by what was before it. So now I'm going to say, I really had to stop hitting the sound effects by accident. And now I'm going to say let output equal TF layers.dense. And all I need to say is units, 1, activation, sigmoid. Okay? Then all I have to do is say model.add hidden, model.add output. Okay? So this is the model. Now, one thing I need to do is I definitely need to import the TensorFlow.js library, which I happen to have from one of my previous examples. So I'm going, right now I have the P5 libraries in my index.html plus my crazy neural network thing and my actual code in sketch.js. Someday maybe I'll use the fancy new import syntax stuff. Let me just have everything kind of line up. Let me add this in here. So now tf.js should be there. I should be able to go back and run this and not see any errors. Aha! tf.layers.sequential is not a function. Sorry, I'm seeing things in the chat. Chat's really off the rails with this XOR thing. All right. So I probably just didn't name tf.layers.sequential the right thing. You know, I could go look. By the way, I made an example. Oh, it's just tf.sequential. Okay, so all I want to say is I just got that wrong. It's tf.sequential. So, you know, I could go look. You know, hopefully I would find this here. Tf.sequential. Yeah, models creation. There it is. Tf.sequential. So I just had that wrong. Okay, let's try refreshing this yet again. Slider is not defined. Hold on. Sorry, Mathieu. I have to turn the notifications off on my watch. I'm getting like phone calls and buzzing things. Okay. Take a minute here. Somebody said that I'm good at drinking drinks in profile, that I could be like a coding train brought to you. Ooh, I'm Buzz Marketing Clean Canteen. Not an official sponsor. Okay. Where was I? Right. All right, let me fix this learning rate issue, 0.1. I just want the thing to run. Okay, so it's still working with the my neural network library, not the new TensorFlow.js one. But let's keep stepping through. So what am I missing here? So when I make a model, now I've architected the model. I've architected this particular architecture, but I need to do another step. I need to compile the model, and I need to define the loss function and the optimizer. Basically, I need to say, like, okay, well, this is how I'm going to determine how well the model is currently performing with the training data and testing data potentially, but I'm not getting, testing data will come in my next video about classification. But here I'm not making a distinction between training and testing data. I'm conflating those two concepts, which is a big mistake and a problem, but we're stepping through this stuff little by little, like a butterfly flapping its wings. It's not at all like a butterfly, but I felt like I was being like a butterfly. And then an optimizer is what sort of function, what sort of algorithm am I using to adjust all of the weights of all these connections according to the loss function itself. So I need to define those things. I forgot how. I know it's in the thing I made last week, but this stuff just isn't. So let me try to type it out how I think it is, and then we'll go check. So I know I need to create an optimizer. TF optimizer, like this, and with a learning rate, something like this. Like I want to use stochastic gradient descent with some learning rate. That's not correct. This is me like trying to remember what the code is, and then I need to say like model.compile, and then I think when I compile it, I'll say things like this. I'm going to compile it with this optimizer and this loss function, like root mean squared or something like that. So this is what I'm remembering from when I looked at this at one time. Now I probably got this wrong. So let's actually go look at the API docs. Well, first, what's the chance that any of this actually makes sense? Okay, TF optimizer is not a function. So let's see, how do we create the optimizer? Optimizer. Yes. So it's this is what I want. I want a tf.train.sgd. This is how I create that. The optimizer is not a keyword in the API. I imagine that for myself. So I need to say tf.train.sgd and then give it a learning rate. So tf.train.sgd. And there are other kinds of optimizers that I think I've even shown you and we'll use more, and give it a learning rate like 0.1. Then I want to look at model.compile. Let's look for compile. Well, we can see it in some examples here. What I'm looking for is where the actual compile, there it is, compile. So the compile function compiles it and give an optimizer a loss. And I can also do some metric stuff. I'm not going to worry about the metrics too much, although maybe I'll try to come back towards the end of this video. OK, model.compile, optimizer, loss. I think this might actually be fine. Is it root mean squared? So let's look for the loss functions. Loss, root mean squared. Oh, why did I keep saying root? I'm on the floor lying down because I'm so sad. I said root because I have it in my head from something that I did a very long time ago where I was always taking the square root of the mean squared error. So I always say root mean squared. There's no root here involved. I guess I have to get back up and continue this tutorial. How long was I saying root for? And how annoying will that be for the people who watch this later? Okay, whoop, I have to get up slowly, otherwise I get kind of lightheaded. All right, apologies. I've been saying root mean squared error because I'm stuck in this world where you have to take the square root, which you don't need to do here. So just mean squared error. That's all I need. This is my loss function, mean squared error. Now, let us now go back here, hit refresh. All right, things are happening, things are going. So the model is built, the model is compiled, and the next thing that I am ready to do is now actually start putting data in the model. Time out for a second. Why did I lose? All right, just give me a second here. I really have to watch the time. I've got an hour. I have to be at Little League practice. I am not a strange 44-year-old person who plays in Little League, but my son is playing Little League for the first time this year. I have to be at the practice. Cannot be late. So I have another hour, though. OK. I'm not the coach. Don't worry. I'm just stand by the side, I cheer, do my hold my little signs. That's it. I don't have any signs. Should have signs. I was actually thinking of sponsoring a Little League team, like the Coding Train sponsored Little League team, but I didn't get it together this year. Maybe next year. All right. All right. These are two next steps. Oops. Oh, why is this completely died? Okay. I know I'm saying 44 a lot because it's about to be 45, so I feel like I might as well say 44. I like the number 44 much better than number 45 for a variety of reasons that I will not get into right now, if anyone can figure out what I'm talking about. All right, it's pretty obvious probably. All right, so the two things that we need to do now. What are the two main steps? I don't know why I came over here, but since I'm over here, so first of all, I drew this truth table thing a little bit weirdly, and so you might recall, just to be clear about what's going on, this is my little drawing of the canvas right now. And the idea of the canvas is that I want to see what the neural network thinks false, false is at 0, 0. I want to see what it thinks true, false is at this top right-hand side. The bottom left-hand side, I want to see it 0, 1. And then I want to see here 1, 1. So false is black. for 0, and true is white for 1. That's the way I'm going to map the color. So I should see some kind of bands of like, I should be getting like something like this. So darker here and like this. So let's go look. Does that match? Yeah, that's exactly what I'm seeing here. So the reason why I came over here is there's two things that I need to do. Number one is I need to train the model to produce this output, my desired output that I think it should do. And then I also need to ask the model to predict so I can draw what it thinks its output is. So the two, so the two steps here, I don't run out of space, but in the TensorFlow.js library, I need to look at the predict function and the fit function. Predict for just saying, here's the inputs, what is your output? The fit function for saying, here's labeled inputs, inputs with known outputs, optimize yourself according to that. So I'm going to do things backwards. I'm going to do just the predict step first. I just want to see when it starts up with no training, what visual output do we get? So coming back to the code, let's look here. So this is what I need to replace. I need to say, let, y equal model.predict model.predict. Now let's go look at the documentation, right? I need to send in the inputs. So let's go back to the documentation, model.predict. I need a better way of browsing this documentation. Here it is. So I need to, model.predict, I need to give it the x's. What are the x's? This are the x's. But remember, I'm using TensorFlow.js now. TensorFlow.js. Oy vey gewalt. I have to make them a tensor. I can't use regular arrays. So I could say, let x's equal tensor 1D. Sorry, I got confused. tf.tensor 1D inputs. And then model x's. Now here's the thing. So this is the idea. There's many problems with what I've done so far. Okay, many problems, which I will solve slowly. This could be a very long video. I apologize in advance. You can take a break now. Pause. Take a break. Go do something else. Come back. So what's problem number one? Problem number one is predict happens asynchronously. Oh boy. Pause for a second here. How did I do this? So I made an example. I just need to think about this for a second. Wait, my glasses are steaming up. Why is it getting all warm in here? Hold on. Oh, and Eric, thank you for that pull request. I probably should merge that and then look at, because he probably fixed a bunch of things. I just want to see something. Now we do this as a batch. Oh, no, predict happens synchronously. It's fit that's asynchronous. Oh, good. That's why I'm doing this. Right? Predict can happen synchronously. Let me look at, I should show you what I'm looking at. I don't know why I'm looking at it on this other computer. Oops. I'm just looking up some stuff for how this stuff works. Oh, wait. No, hold on. Let me show you what I'm looking at. Because I don't know why I'm looking at this. So I have a repo called 145. It's not called 145 this is the time. TensorFlow.js examples, XOR, sketch, right? So I know I have to do it as a batch. Neural network predict. Oh, or did I do it? And so I was putting it in a class, which I'm not going to do here. Tidy return. Oh, no, predict happens synchronously, but then pulling the data off happens asynchronously. But I can use data sync, even though I probably should be using TF next frame. I don't know how to use that yet. So I will deal with that later. OK, sorry. OK. OK. Here I am back. All right, sorry. I'm going to just back up a bit. Mathieu, you can splice things however you feel so inclined. Whoops. So I need to ask the TensorFlow layer sequential model thingy to give me the y. Model.predict. But what does it expect? Its predict function, unlike my predict function, cannot get a regular array. It expects a tensor. So I need to make the x's into tf.tensor1d with those inputs and pass those through predict. Now here's the thing. There's a lot of issues with this that I need to resolve. And this is going to run really slow, and I need to actually do this as a batch process. I'm going to get to all that. But just looking at what I've got so far, model.predict, there's a question of like, is this happen synchronously or asynchronously? This actually is happening synchronously, but the problem is I need to say fill with the result. Like I need to get that number out. And to get the number out, I actually want to call .data, and that happens asynchronously. So because I'm working with such teeny bits of data right now, I think I'm going to use data sync, and there could be issues with that. And as I move more forward, we're going to see when I really need to be more thoughtful about callbacks and promises. But I'm going to use data sync right now. So I should be able to predict the output with this input, get that data, and then let me just say console log y. And I'm going to make the resolution here of the the resolution really big, like 50, because I just want to like look at very, very little data to start with. And let's look. I'm not going to draw anything. Let's just look and see what's coming out. What's coming out here? Y, and then let me just say no loop. So let's look in the console and see if we get anything. Error. Expected when checking dense1 input to have 2 dimensions, but it got array with shape 2. Oh, once again, I have the same problem I've had every single time I've done this with TensorFlow.js. So the good news is I don't want to just give this 1D tensor. Even though my data is just 2 values, 0, 1, 1, 0, 1, 1, and it's a one-dimensional array with 2 numbers in it, I actually want to be able to do something like, hey, take these 15 data points and give me the results, the predictions for all 15 of those. And so what I really want to be doing is I always need to send in kind of like 1 order higher, 1 degree, 1 rank higher. So this actually, I'm just sending in 1 piece of data endpoint. Input. Brain stopped working in the middle of this video. That's 17 hours long. And this now I also have to say tensor 2D now, because it's a 2D tensor. There we go. So we can see, look at this. The results came out for all those little spots. You can see little numbers between 0 and 1 in an array. So now I can, instead of console logging y, and I just want that, it comes back in an array, but there's only 1 number I care about. I can put this back in here. I can take out no loop. And I can run it. And we can see, look, there is my current visualization of XOR. I'm not really done. I have so much left to do in this video that is been recording for the last 3 or 4 days. All right, one thing I want to do is I just want to say stroke 255. So I just want to sort of see a little bit more. Okay, that's actually what I'm looking at here. I actually want to make the resolution, for debugging wise, I also want to make the resolution a little bit bigger. So let's see. Now, one thing I'm curious about is let's look at the frame rate here. It's running at 30 frames per second, so that's fine. Let me now actually make the resolution much, much higher, like this. Oh my goodness. Oh, it's not even getting to the first frame. Oh, oh, there we go. Look at the frame rate. Oh, it can't even give me a frame rate. It's so stuck. It can't even get 1 frame per second. So here's the thing. I have done something very, very, very bad. And I need it to stop. No loop. Stop. You don't have to do any more work. And let's put the resolution back at 100, and let's think about this. What's going on here? Look at this. Look at this predict function, and look at this data sync function. What am I doing? I am calling that function multiple times for every single spot on that grid. When I'm working with something like TensorFlow.js, whenever I create a tensor or feed data into a model, the data has to go from my code onto the GPU. And then when it's done, that data sync is pulling it off of the GPU so I can use it again in my code. That graphics processing unit where all the math is happening behind the scenes. I want to do that as few times as possible. Look how this is, I'm creating this 2-dimensional array with one thing in it, 100 times. I could just create one array with 100 things in it and call predict once. That's what I want to do. So what I need is for this nested loop to happen twice. Once to set up the data and another to draw all the results. So I'm going to copy paste this, just put it right below. So this now what we need to do is create the input data. So I'm going to say let inputs be a blank array. Then I'm going to say inputs dot push, and I'm going to just push in x1, x2. So I'm going to put every single x1, x2 all the way along. I don't want to create the tensor or do this here. I don't want to do the drawing stuff here. I just want to have a loop that creates all of the data. Now, I can get the x's is all of those inputs into a 2D tensor, and the y's, this is now the y's, is, and now here's the thing, so hold on, I got to look at what that's going to look like. Let's comment this out for a second. Let's look at the y's and see what that looks like. Oh, okay, sketch.78 error. Oh, no let there. Just inputs push. Okay, I want to say no loop. Let me leave that no loop in, put it back. I just want to look at it once. So you can see, what did I get? I got a big array of 16 numbers. I got all the results. So now what I want to do is, back here, now I just need to do the drawing. And I don't need the input data, I don't need the model. All I need to do is draw, and I need to say fill y's index what? I plus j times the number of columns maybe? Right? Because this is a one-dimensional array to describe each spot in that grid. I could do something like, maybe I'll just do this. Let index equal 0. I'm going to say fill based on this particular one. And I don't need this even, sorry. And I just need to say then index plus plus, right? So what are the steps here? Create the data, get the predictions, draw the results, okay? There we go. So now we can see this is working. I mean, it's not doing anything, but now let's check this frame rate question. We don't need to console log the y's. I'm going to get rid of the no loop. Let's refresh this. Let's look at the frame rate. 30 frames per second. Let's pump it up a little. Let's pump you up a little. Where was the resolution there? Let's make this 20. Don't want to go crazy. And look at the frame rate. There we go, 30 frames per second, no problem, because I'm only one time through draw trying to copy data onto the GPU and get it. I'm only calling predict once. And we can, just to check, we can go to 10. And we can look at the frame rate. And you can see it's like kind of running a little bit slow, but this is because I'm not being too thoughtful about the asynchronous nature of this stuff. I could do other things to optimize it, but I'm just going to ignore that and leave it at, let me make it 25. Hey, time out for a sec. This should definitely be multiple parts. Oh yeah, create inputs at the start, they are constant. Oh, that's such a good point. Okay, I'm going to do that right now. That's a very good point. Who said that in the chat? Probably lots of people have. Pre-calculate them setup. Error. A bunch of people have. Yeah, okay. This. All right. All right, everybody's saying that. All right. The chat is giving me some even further optimization, which is, why am I bothering to do this in draw? This is something that these inputs never change. I can just do them once at the beginning because they're, and I can ask for them many times in draw. So let's actually fix that. So I'm actually gonna take this and say I'm gonna make these global variables. I don't know if you guys can hear the music that's coming from the room next to me, but it's there. All right, then, but the width and height does not exist until after create canvas. So let me do this. And let me do this. Okay, so now that's there. Now I should be able to take this, the input data, and put this right here in the beginning. And then I'm going to make a variable called x's. And x's, and where did I do that? Here. And then create those x's. So I'm now doing this in setup. And then in draw, the only thing I need to do in draw is run the predict. This is going to make things run a lot faster. Let's make sure it still works. Here we go. Okay, so you notice we get like a different color each time I refresh because the neural network model, the sequential model, is initializing everything randomly. But now I get to train it. Yes! Now I think we're ready to train it. So here is what I did when I had my own JavaScript neural network library. I called neural network.train data.inputs data.outputs. Sorry, I'm reading the chat. You guys couldn't hear the music? Well. All right, so if only I could remember exactly what I wrote when I made that TF layers tutorial, but I know that what I need to do here is I need to do something like this. Model.fit some x's and some y's. That's the training, that's the equivalent, and the learning rate is irrelevant. And I don't necessarily need to do a loop. This is basically what I want to do. Every time through draw, I want to try to fit the model with some training data. So let's first make the training data. This is not exactly right. I need to figure out, and I need to use a weight. I need to think asynchronously, but this is the idea. So if I go back to the top here, this is my training data. Now, one thing I definitely need to change is I'm going to keep the x's and y's separate in training. So I'm going to do this is, I'm just going to do this kind of manually, because what's the big deal? So let me make the training set, and then 1, 1. Those are the x's. Now let me look at the y's, and the y's would be 0, 1, 1, 0. Then I need those to be tensors. So I need to say const tf x's. So I'm trying to think of good naming for this. I kind of want them to be called, actually, you know what? I'm just going to call it, do I have a global x? Yeah, I have a global x's already. Tf x's equals tensor 2d, tensor 2d, tf, tensor 2d. You know what I'm going to do? I don't need these, I don't need two separate sets of variables. I'm just going to create it. I'm going to call this, everything is so much more complicated than I make it. So much more simple than I make it. I'm just going to make these tensors directly by saying tf.tensor 2d. And then I'll put the parentheses around this. And there, now I made it a tensor. Then I'll say tf tensor 2d. And now I made this a tensor. OK. Now we're good. I've got the training data. And I'm going to get rid of this. This is the old way that I had the training data, which is totally unnecessary. So the training x's and the training y's. Are you with me? How have you been watching? If you're still watching, I don't know. Get up and do some jumping jacks. Let's see. Now, I need to do model.fit. Now, model.fit happens asynchronously. So let's put it in its own async function called train model. Now, if you don't know what it means to write a function that is tagged with the keyword async, this is part of ES8, a very newish version of JavaScript, and I made a bunch of videos about what that is that you can go back and watch. But this is basically a way for me to now say await model.fit, and then let's look at the fit function, model.evaluate, compile, predict, fit. So what I need is to give it the x's and the y's. There's batch size I'm not going to worry about. There's epochs I'm not going to worry about, or epochs. And so h will give me back the history. So let's just see here. I'm now going to say train model.then h console.log h.loss index 0. Let's say no loop again. So basically what I'm doing here is I want to call this function train model, and I'm using this idea of promises. It's going to await the model, and I need to return. Do I say await return or return await? No. I must say return await. Return await model.fit. So I'm going to return a promise which will have the result of the fit function. And I don't know if this is right. I want to just look. I want to do that. I want to call to train model every time in draw. I might need to do this somewhere else just for right now and then see what the loss is. OK. Onyx 73. Async function. Async function. I've got to say function. Function. It's an async function, not an async. There we go. Y's is not defined where? In train model. Oh, right. This is, I forgot, I called it train x's and train y's. So my training data, train x's and train y's. Isn't it nice how the word train just appears everywhere when you're doing machine learning? Drink your glass of milk or whatever it is you're having while you're watching this coding train stuff. Cannot read property 0 of undefined at train model then h. All right. Let's just console log h. I don't know what that is, what I've done. OK. History. Loss, 0. Okay. I wonder what it, by the way, I didn't give it any testing data. So what's it computing the loss from? History. So this is, I'm going to call this result. Result, history, dot loss, index 0. All right, there we go. There we go. Now let's let it do that over and over again in draw. We're waiting. All right. So this is a bit of a fail here. Oh. No, if we're returning the promise, that's a good point. All right. So I let this run a little bit, and unfortunately you can see it's getting nowhere. This loss, which I'm not sure exactly how it's calculating that, I'll think about that and come back to it, is not going down anymore. So what could be some problems here? Number one is, well, maybe my learning rate is no good. Not that it's no good, but maybe it's too low. So where did I set up that learning rate again? And let me get rid of, by the way, I just want to now delete. I want to make sure I'm not using any of my old neural network code. So I'm deleting all references to that. So this is now purely TensorFlow.js, and let me refresh and run this again. And let me look into sketch.js and find where did I set the learning rate right here. Let's set it to 0.5 and see what we get. Yeah, it's getting better. I'm going to let this run for a little bit and I'll be back. Let me look at. So one thing I want to do also is I want to write, it looks nice if I write in the numbers actually of what the output is, where it is. You can see that it's actually getting there just very slowly. Just want to see what settings I used in my other example. Try different optimizers and activation functions. Yeah, I'm going to do that in a second. I want to get it to work with this first. I just want to see what settings I used. Oh, did I forget to put shuffle in? It should shuffle it by default. I wonder if I... you know what? I forgot to put shuffle in. It's actually working. All right, I'm back, and you can see the loss is now kind of much lower, and you can start to see the visual that I'm expecting, which has a true value in this corner, true value in the top corner, and sort of darker false values in those corners. But it's still kind of performing rather poorly. One thing that I forgot to do is when I call the fit function, there are a set of options that I can pass in for the number of epochs and all sorts of things. But one of the ones that I really want to pass in here is called shuffle. Shuffle takes the training data and it shuffles the order of it each time. Right now I'm training it with the same 4 data points in the same order every time, which could be a bit of a problem. And OK, so let me now, let me hit refresh here and run this again. Whoops, I can't see the frame rate because. Time out a sec. 0.5, optimizer. Oh, optimizer, yeah, this is all the same. Sigmoid, sigmoid. Data. Train. Am I giving it, oh, you know what I probably did? No, I thought maybe I was giving it more epochs or something. Shuffle for XOR is not a big help. Apparently not. One thing I'm curious I could do, just out of curiosity. Because if I go to that thing I was showing you, everybody, where this should be hosted via GitHub Pages. For loop and epochs will really help. Yeah, I just wanted to see, like, I'm pretty sure, I don't know why this isn't loading. I mean, the other thing is I probably should create a separate, I mean, there's no such thing as a thread, but I probably should have, right, I should just run the training, like, this async function I should just, like, I don't need to, like, I shouldn't be calling this in draw. But I just wanted to start doing that. I was going to fix that later. What time is it? I have a half an hour. And get through this. Whoops. Why is this not loading? Oh, is it because, oh, it's probably because this is running. I don't know why my example, I wanted to just see the performance of my example. Hold on, I think I need to restart Chrome. Whoops. Why is this not working? Here we go. Yeah, I know I should do, like, I was going to do the set interval thing, but I actually wasn't going to do set interval. I was going to do set timeout and then have it, like, recursively call itself when it's done. I got lost in, this is not important. I just thought I could run the thing that I made before just to see how it performed. But I don't know what it's stuck. Is anybody else try running this example? Maybe I'll merge Eric's pull request. It's like stuck. Weird. Okay. Yeah, that's what I wanted to do next frame. So let me come back to that. I didn't want to do that first, but yeah. But thank you for that. Oh my goodness! I forgot to tidy everything. Oh, well, but yeah, the y's I need to dispose. And I also need to tidy this. Oh yeah. Hold on, let me at least just go back to where I was. I'm going to let this go for a little bit. Just want to... Did anybody see what that was? There it is. Where is it? Yeah, look at that. That's a mess. Okay. Okay. All right, so things are still working, but it's still running kind of slow. We can see I'm getting the loss down. Hold on. Let's see. Okay, things are working. It's getting kind of getting close to the right result. You can see the loss is going down. I've realized, thanks to the chat, of course, that I forgot something really important. I want to try to make it learn faster, which I will kind of get to, and I want to think about the sort of asynchronous nature of using P5's draw loop and using the model.fit at the same time. But before I do any of that, I just realized I haven't thought about memory management at all. And there's a big problem with this. If I just take out for a second this, and let me do this here. Take out this console.log, and I run this again, and I look at, say, if I say in the, oops, yeah, I'm like killing my computer. It can barely run it again, because watch what TF memory num tensors, 3,455, 4,479. I'm just generating tensors. I'm filling up all the memory. Performance on this is going to be a disaster. So let me stop it before it gets too bad. And let's see, where do I need to do some cleanup? So these X's, these training tensors, I never need to clean those up. Those I can keep forever. But in train model, I should probably TF tidy this whole thing. Let me think about that. Let's first actually, the Y's, after I do this, I can just dispose those. So the Y's I definitely need to dispose. Let's at least just do that first, and let's see what, where that gets us. Whoops, look at this. Because I use data sync, I could use TF tidy, but what I'm going to do now is Y's, and then I'm going to say let Y underscore values equals Y's dot data sync. I can't clean it up once it's also been data synced. So now I do Y's dot dispose. Whoops, do I have no loop on? Nope. And still going up. That's weird. Oh, this has to be Y values. Also, I have to change that to Y values. So that helped. This video is so long. Now, what I want to do is I need to, let's just do this. TF tidy. Let's just put the TF tidy here. So like whatever happens in this function, just tidy it all up. I could put it probably up here. It's the model.fit that I need to tidy, but I'm just going to do this. Let's do this. 540, 900. Ooh, I'm still missing something. What tensor is being created over and over again that I didn't tidy? It's 220. Oh, this is turning into a disaster. What did I not tidy? I guess maybe I need to put tidy in here. Like, or I can just say like this, right? Hold on. Oh. I'm so confused. Like this? No. I'm so confused. Hold on. I have to make the arrow function async. Yeah, I'm like lost here. Let me back up for a second. This is why I wanted to tidy outside of it. Get rid of tf tidy for a second. What did I have to start? Can I just put this here? What am I missing? I can't use promises in a tidy. Oh, right. So I was doing this right. Hold on a sec. What was wrong with what I had here? What was wrong with this? Like, why is this? This should be fine, right? Which version of well, let me also go back to making the resolution much bigger. Oh, I had it right before. I just didn't hit save. Ah! I'm gonna do a backflip. Ready? 1, 2. No, I'm not doing a backflip. I had it right the whole time. No. Well, that's so weird. When the resolution is higher, I have a memory leak? Huh? That's weird. What am I missing? Why do I have 3 in there? That was weird. I'm like going out of my mind here. So what is it? What I have some like weird bug here that I'm not thinking of. X's. All right, let's. Let me tf tidy this whole thing. So y with a different resolution that's so weird. I feel like this is a bug. Yeah, the slower the resolution, the less early. I sort of feel like there's some bug that's not my code. I can't figure it out, but tidy here kind of fixes it. I don't think that this needs to be, this is just an array. So this doesn't need to be cleaned up. I mean, the garbage collector should, that's not a tensor. But did I make some other tensor in here that oh, I guess model.predict, maybe it makes some other tensors behind the scenes. Okay, you know what it is? I'm just being silly here. I think I'm like forgetting that model.predict, just like model.fit does other, okay, Mathieu! I'm going way back in time, way back in time, too long ago. And I'm going to do my memory. Why did I make that 3? I'm going to do my I'm going to go all the way back and memory leak it again and fix it. Yeah, the epochs will definitely help. Ooh, modeling evolution with TensorFlow.js from Siraj Raval. New video out. All right, I just want to get this down a bit, and then I'm going to come back. All right, here we go. I can't look at the chat right now. Chat. All right, so you can see it's kind of working. I'm back. It's sort of taking a while, but I want to get this to train a little faster. I want to get a little further with this. First of all, I was reminded by the chat that I've forgotten something really crucial and important, which is memory management. And I really should stop this from running right now because there's a huge memory leak happening, which I haven't cleaned up any of my tensors at all. Whoops. Don't look at that. Hold on. I forgot that it was there. Okay. Oh, and this is there. Sorry. Just do this again. Sorry, everybody. One more time. Shoot. Yay, memory leak. Okay. Really need that ukulele. Ah! All right. Well, look at this. All right, so it actually is working. It got the correct training result. It's a little grayscale-y in a way that I would like to be able to emphasize visually what it's doing. But you can see the loss has gone way down, but it took a while to get there. But I want to add a few things to this and try to fix it up a little bit. Before I do anything, I was reminded by the chat being over here that I haven't thought about memory management at all. So I'm going to say like no loop for a second to just sort of turn this off. Then I'm going to say memory num tensors. Oops, no, wait. tf.memory dot num tensor. I know I'm trying to use, I'm going to say num tensors. tf.memory num, there it is, I can get it, there it is. 32,205 tensors, that's crazy. So I need to deal with that. I'm just making tensors and letting them leak everywhere. So I could manually run dispose, but I've got kind of an issue, whereas predict is going to like make a lot of tensors behind the scenes, as well as model.fit. So I can use the tf-tidy function. So I'm going to say tf.tidy, and then I just need to, I'm going to use the ES6 arrow notation, which you can watch my videos about what that is, and I've kind of gone through what tidy is. Tidy says anything inside of this code, clean up the memory afterwards, basically. And then I probably could put this around everything, but I just want to, and I don't need this stuff anymore, I just want to keep these two areas separate because I think I'm going to, at some point I really should change the way doing the fitting of the model, in draw is somewhat problematic. So now I'm going to just tidy all of this. I think that's right. Do I have an extra parentheses there? Yes. Okay, so now let's run this again. Let me comment out this console log. I don't want to see that right now. Oh. All right, and now let's look at the number of tensors. 15, 15, 15. So now I've gotten rid of the memory leak. Let's check out the frame rate. 30 frames per second. So this is running for a while. Now, I just want to be able to look at what's happening a little bit better. So I'm actually going to draw the number of the output inside each one of these things. So let's do that. So where am I drawing the rectangles here? I'm going to say let the brightness value equal this. And I'm going to fill the rectangle with that brightness. And then I'm going to say fill 255 minus, like the inverse color. I'm going to say text, number format, the y values index with just 2 decimal places. And I'm going to put that at, boy, this is awkward. The x values, this is going to be I times resolution plus resolution divided by 2. I'm going to say text align center, text align center, comma center, and then I'm going to put I'm just going to draw in the center of the rectangle, and this should be J, the text. So let's do this now. So we can see, ooh, look, there's lots of numbers there. I think my number format thing didn't work. 1, 2, and let's use a lower resolution just so I can see it better. There we go. Now, interestingly, I can't see the numbers, but there they go, right? You can see this is what it's getting, the output for each one of these. And I want to look at the loss. You can see, because it's just going so slow. It's getting a little better. It's getting a little bit better. So over time, it's getting a little better. But I really want to see it train much faster. So let me see. I have one idea, one last thing I can add to this, even though I have some suggestions for what you might do next. But you can see, the numbers are starting to appear. Lovely. Because I forgot when it's gray, when it's at 0.5, 255 minus 0.5, it's going to be the same color. But I kind of like that effect. So, so what I want to do is, what happens here if I actually tell it, don't just do it once. Like do it 10 times. Do 10 epochs per cycle of fitting. Let me run this again. And let me look at let's actually have the loss continue to print out. And there we go. Still running pretty fast. You can see the loss is going down. And relatively quickly, I am getting myself to the point where I'm starting to see, this is definitely getting all the way down to 0 there. This is getting way up to 1 there. It's getting a little bit stuck. It's having trouble with this side. I imagine it'll get there eventually. We could do some fun stuff. For example, I'm going to just let it have, it's totally unnecessary, but I'm going to give it 4 hidden nodes. And I'm also going to put the resolution back to 25. And let's run this again. And let's see how this goes. So I'll give it a minute. I'll come back. Oh, the font is too big. But you can see it's learning pretty quickly right now. Hold on. Well, let me go back, do that again. So I'm going to give it, for no real reason at all, but just for fun, 4 hidden nodes. And I'm also going to, let me change the resolution to 25. Let me make the text size something like 8 point. And let me, oops, refresh it. Why did it, yeah, I want to. All right, I let this run for a bit, and you can kind of see here. Now you can see all the XOR values. Here's a nice, beautiful little map, grayscale map of all XOR. It's getting all the way up to true and all the way down to 0 at the corners. This is pretty good. So, and this is running at, if I take out this console log, I can now take a look at the frame rate. It's running kind of slow. So here's the thing. I have done something that I don't like, which is this train model is being called inside draw. And I really shouldn't be doing that because I don't want, I don't want to call train model over. I can call train model. Well, let me think about what I'm saying here. Yeah. I have to, how did I finish this up? I have to go in just like a minute. I'm trying to think of what I want to finish up here. So I don't think I have time to do the TF frame thing. But would it make sense for me to at least do something like set time out train model? Like just say, hey, do that. And then like what if I did this? Function train, set timeout, train model. I want to do like a then, but well, or what if I just did this? Like something like this, right? This is what I'm thinking. And then this would, right? Does this make sense? Hold on, I'm gonna explain this in a second. Like this would basically be happening elsewhere. But I think I need the set timeout to like, yeah, this is never going to release anything. Oh, this is like superfluous because it's just returning a promise. Yeah. All right, I'll do that. Like what if I did this? This is weird, though. I've killed this completely. Killed the browser. It's not really that much faster. But this is kind of like what I want to do, right? Yeah, now I can get a much faster frame rate. And I could actually give it more epochs, right? Yeah, the training is happening more slowly, but the frame rate is happening faster. Perhaps it results in a video about workers. What tidy does nothing? Look at this crazy way that it learned. Where's a tidy that does nothing? Me, I am Sumi. Right. Is this an improvement over what I had before? No, I need this TF tidy. What? Because this has to get tidied. Right? This is what it's doing right now. If I take that out, oh, you're right. Oh, I don't need a TF tidy for model.fit? Okay. Okay. Is this an improvement? Like to have pulled this out, at least pulled this out of draw? And away. Model.fit is tidied internally. Okay. Ugh. And tidy doesn't work with promises. Got it. Got it. All right, is this an improvement, or should I just stay where I was and let it be? Like leave it in draw and talk about how that probably should do TF frame instead, web workers, yada, yada, yada. Answer fast. I gotta go. Async while loop is definitely a good suggestion. Technically, this is a much better way to do it. All right. Thank you. That's all I needed to know. Okay. Okay. So I'm going to go back to, all right, so the chat has given me some really helpful tips. I've made quite a few little weird little errors and mistakes here, and I want to just fix this up a bit. I think it's actually going to be easier to look at and watch if I just go back to a lower resolution. So let's make this 40, and let me refresh this. Okay, so here we go. So this is now working, training itself for XOR. You can see it's kind of moving along here. Now, what the real thing that's problematic here is the draw loop is happening over and over again. And then I'm triggering something asynchronous in draw, and I could be asking to train the model before it's even done with the previous training cycle. So this really should not be happening in draw. Now, TensorFlow.js has a function called TF next frame. I want you to explore it and make a version of this with TF next frame as like an exercise after this video is over. But I'm going to do it a different way without that because I got to come back to that in a different video. But first of all, this I also learned, this is totally unnecessary. The await, a couple things. Number one is, because there's just one thing happening in here, I could just return the promise. This doesn't actually have to be an async function. And then I do not need the TF tidy because model.fit kind of will clean itself up automatically for you. So this should still work just fine. And I should be able to see the number of tensors is still 15. So that was something that I didn't need that I've now fixed. Now what I really want to do is I want to get this out of draw. So let's comment this out here. And what I'm actually going to do is I'm going to write a separate function called train. And in that function, I'm going to say set time. OK, wait. I'm going to call train model. Wait, hold on. I'm going to call train model. Yes. In that function, I'm going to do this. So I'm going to separate function that does this piece of it, that console logs the history. And I could use, and what I want to do is I want to say set time out, call the train function in 100 milliseconds. So I want to just let the program start, say 100 milliseconds later, call this train function. Train the model, which does the fitting. When that's done, log the history, and now say set time out, train 100. So this is sort of like recursion. I don't want to use set interval here because I only want to call train again once it's finished with training the model itself. So this is kind of like, hey, train. And by the way, I could just increase the number of epochs or maybe do some kind of loop. But I think this will be a sort of nice way to demonstrate it. And if I just called train directly, without a set timeout, I'm never going to be giving back control for a second. I could end up with sort of like blocking. So I might even be able to get this down to like 10 milliseconds, just something really, really low. So let's run this and sort of see. Same result. We can see, there we go. Things are working, but at least now I have gotten that out of draw. So draw is happening on its own. And in fact, what I could really do is I could say, hey, try doing this with like 100 epochs each time. Epochs? What is it? And you can see the loss function is coming out much more slowly. But the frame rate, let me just clear this for a second. The frame rate is quite fast. Hold on, this is too confusing. I probably need to give it back more time. Let's do like another little break. I just want to like take out the console log thing so I can look at the frame rate. I should just put the frame rate in the DOM. Wouldn't that be smart? But you can see now I'm getting 60 frames, 30 frames. Well, I'm getting like a pretty high frame rate, even though the training is happening. It's kind of like there is no threading in JavaScript. So these things are just like passing off. And really, this might be a place where like web workers or something could do the training behind the scenes in some fancy way, which maybe I will get to at some point. Oh my goodness. Alka is suggesting it might be better to use the draw loop and a Boolean to know when it's safe to call it again. That would also be a good idea. So you can see what kind of like, I'm pulling my hair out, what kind of sort of like hassle situation we've gotten in. But really, let's just put this back to like 2 epochs. Let's put this to like little 10 milliseconds. And we can sort of feel like, there we go. And I can look at the frame rate. It's running nice 30 frames per second. And at some point it's going to get there. What's that loss? I forgot to console log the loss. Come back to me. Come on. Oh, but let's see. I have an idea. What if, just before I go, what if we try using a different optimizer? What if we try using, for example, a different loss function? Hold on. This video is already 18 hours long. What if, oh, no, a different optimizer, sorry. What if I tried using the atom optimizer? So let's just try that just for fun times. Let's give it a lower learning rate. Whoa, look at that! Woo! Boom! Yeah! Wow! All this time. That was pretty exciting. Let's go. Let's make the resolution back to like 20. Let me make the font size like nice and tiny for us. Let me give myself some more space here. Hit refresh, and then let's look at this. Look at it learning there. Ah, look at that. That is beautiful. Look at it learning XOR so nice and fast. I'm just going to hit refresh again. We can see it. All right. So we can see, we really should look at what this atom optimizer is. I will link to a paper and some more information about what the atom optimizer is. You can find out, actually we should just go. Yeah, I'm sorry, I'm like. This one. Hold on. I should really talk at some point about what some of these other optimizer functions are. For now, what I would suggest that you do is if I go back to the API reference and I go all the way down and I find let me just look this way. If I go here and I go train out atom, we can see here, this is what you're going to want to click on. This is the paper that describes the atom algorithm. It's different, but it's optimizing the loss function in a slightly different way than stochastic gradient descent does. We could also try starting to we could just never stop, and I could start I think using the ReLU activation function instead. Whoops, is that not what it's called? Where are the activation functions? Oh, there's no, it's just all lowercase. So there's just so many things you can play around with these things. That was a failure. I think because I have the, all right, I'm not going to add, I'm going to, hold on. Back to where I was explaining the atom optimizer. Oh, it made this such a mess to edit. And I really have to go. I really should explain what these optimizers are, but if I go back and look under here, we can see what some of these are. Atom, the ADA coming from the word adaptive, and you could always click here and look at this paper, which describes this particular method for optimization, which is a little bit different than stochastic gradient descent. And apparently, things work a lot faster with this XOR problem. So as I go forward into more of these videos, hopefully we can dig into what some of these different optimizers do and kind of understand why I might pick one over the other in certain situations. All right, but I'm just going to leave this be. I'm going to hit refresh. I'm going to watch it, learn and train. Train XOR. I don't know, some things you could do. Investigate tf.frame. Give me a little slider. Try different architectures, different optimizers. Try some different activation functions. I don't know. If you actually made it all the way to the end of this video, I don't know, hashtag something. Eric is telling me to watch one of those videos reviewing the JavaScript event loop, which I definitely need to do. So I'm going to be back with more someday. Goodbye. Thank you. Momentum. Is ADA not for adaptive? Did I just make that up? Adaptive estimates. So maybe the M is for estimates, moments, low order moments. M is for moments. Yeah. All right, everybody. Well, you know, today was one of those days. I should really be doing my old style coding challenges again. Read out of the random numbers book. Okay. Okay. I'm running late. I gotta go. Everyone lie down. Go to sleep. We're gonna, let's artificially make this happen much slower. Let's train, let's go. Okay, ready? $32,985. 26,814. 51,833. 57,363. 4,067. 84,648. 85,505. 41,465. 71,769. 99,550, 55,904. Will there be a second live stream today? No, unfortunately. Will I live stream on the weekend? No, unfortunately. So apologies. I wish I could live stream more often, all the time, make more stuff, blah, blah, blah. The next live stream will likely be next Wednesday and next Thursday. And I'm going to be working on a lot more of this stuff in between. Hopefully we will, the things that I really need to look at are, I need to look at that event loop article that just to get a better sense of how to use this stuff together with the request animation frame better and tf.frame. All right, so any last, if my real time that I had to leave was 3 o'clock, I got 2 minutes to answer questions. Let's try like, I like doing it with like a high learning rate. You can see like it gets to, you can sort of see it bouncing. Look at this, learning rate is too high. It kind of gets stuck. It kind of can't get there. And then if we could do weird stuff like what if I gave the hidden layer 16 units for like no reason? Like, look how, because there's no correct answer. There's only training data at the corners. Ah, it learned a rainbow. XOR learns a rainbow. People are asking me questions, and are you going to do convolutional 2D soon? That's why I hope to plan to, yes. All right, everybody. So this is my list. Oh, thank you, Joshua Myers. That's very kind of you. If I had my Philips light bulb, it would have flashed. By the way, let me just mention, if any of you are sponsors, you can now sponsor the channel through the YouTube interface itself. Make sure you go and check the community tab and look for a post that links to a Google form to enter your email so I can send you an invitation to the Slack group. I need a better system for doing that. I have a thing set up that it actually, like, I get alerts and a spreadsheet and I can look, but I don't get your email address. So there's no automatic way to invite you to Slack other than by doing it manually. Yeah, so this is where I am going to next. I am going to do I want to do the TF playground idea and the classification idea. So if anybody has any ideas for really simple, goofy just like basic numeric data sets. I'm probably going to do something where I'm going to look for some color data set, which takes any RGB set of RGB numbers and like categorizes it in like with a few different like labels. That's one. So if you have some suggestions for that, please let me know at Schiffman on Twitter is probably the best way. All right, everyone. I don't know. Add more layers. Sorry, everybody. I hope you enjoyed today. Somehow. I don't know. Maybe I shouldn't be covering. Next week, maybe I'll try to at least do a coding challenge that's not machine learning related. I want to get through all this machine learning content, but it is kind of overwhelming and taking over everything. Weather prediction, but I want to do classification. So I don't want to do time series. All these things will come, but I want to do a really basic classification. I don't want to use images. I don't want to use text data that's like, I don't want to use time series, sequential data. I just want like it's like house prediction, the iris data set. These are the kind of thing, house price prediction. Well, that's prediction, that's not classification even, but regression. But something like that, but I want it to feel goofy, creative, in the art world space, that kind of thing. All right, tic-tac-toe game. Okay, goodbye everybody, I'm gonna hit stop streaming. I guess I will play you out with my weird trailer, since that's what I do now.
Let's find something we want to make, some crazy idea. We'll figure out what it takes to make that dream appear. We'll try to understand now.
While the trailer is playing, I will attempt to explain why doesn't it dispose of tensors automatically, as asks Ray Jackson, asks Arnav. I don't actually know why it doesn't dispose of tensors automatically, but it's this is the thing that there is no way to clean up the memory on the GPU with a garbage collector in the same way, and this is like a lower level question that I would be curious. We have to investigate more about how TensorFlow.js works.